So in this part, we're going to continue talking about combination of functions, and we're going to denote this as part two. So it's very important that you go back and review part one, because in part one we talked about the definitions of sum, difference, product, and quotient in terms of functions. So remember, when we talk about combination of functions, you're basically taking two functions and you're putting them together. Remember the word putting them together to get a new function. So for example, what we did in part one was we had this function, this function. I put those two together by adding them and I got a new function. See, this function looks totally different than any of these. And then again, the other example was in this case, I put these two functions together by subtracting and I got a new function. Okay? All right, so it's very important you go back and you review part one. All right, now what's going to happen in part two is this. So remember in part one, I added these two functions at x, and notice that when I did that, I got this variable expression, right? Okay, so I got this new function that had terms in it, variable terms. Okay, now what's going to happen here is this. Instead of me asking find f plus g at x, let's say, oops, sorry. So instead of saying finding this, we're now looking at we want to find f plus g at, let's say, 3. Okay, so that's what we're interested in now. So in part one, we combine functions at x. In part two, we're going to combine functions at a value of x. At a value of x. Now, one thing I gotta remind you, you're going to see this. When I combine functions at x, notice that my answer contained a variable expression in all situations. When I combined functions at x, I had a variable expression. When I combined functions at x, I had a variable expression, and so on. What you're going to notice is this. When you evaluate at a number, your answer will be a real number. Okay, so just like we did, remember in part one, if I can find it, let's see, I hope I can find it real quick. Oh, here we go. So remember we did part one? When we first started it, we reviewed something, so I wanted you to find if f of x is this, then what's f of negative 5? So notice that when I evaluate this function at negative 5, I end up with a real number. So it was not a variable expression, it was a real number. Okay, that's what's going to happen here. Okay, so here's how it's going to look now. All right, so how will this thing look, right? Okay, so we're going to have this. So let's suppose, well, first of all, let's remind ourselves about the definition. Let's do that first. So definition. So remember we talked about the sum. So sum means, if you remember the notation is important, so make sure you understand notation. So f plus g at x will be f of x plus g of x. Okay, difference. Now remember we saw earlier that in part one that difference is not commutative, so the order matters. So if I have f minus g at x, here's my question. Can I put g of x first? The answer is no. The order matters, so I got to say f of x minus g of x. And then the next one was product, and so that would be f times g at x, and so that would be f of x, f of x times g of x. And then quotient, and our quotient definition was this. If I have f divided by g at x, and remember order, the order matters for difference in quotient. So if I put if f is in the numerator, then I got to rewrite it and put f in the numerator here. Okay? All right, so those are the definitions that we talked about. Okay, now let's look at some examples now. Very simple. almost every student can handle this. All right, example number 1. Suppose that f of x is negative 4x plus 2, and g of x is 5x minus 6. Okay? All right, let's suppose we want to find a f plus g at 2. F plus g at 2. Well, remember our definition. So I want to combine those two functions and evaluate it at 2, right? That's what that means. Well, by definition, now this is sum, by definition that means f of 2 plus g of 2. That's what that means. Now, the next step, that's not your answer, because the next step is where remember in part 1, if I can find it real quick, that's where you see how this looks right here? And remember this right here? So we had to find, now in this case the graphs were given, in this case the explicit functions given. So you have the individual functions listed here. Here you have the graph listed. But remember what we did though? We found f of 2 from f of x, our parabola. Then we found g of 2 from the linear function, and we add them up. Okay? Same thing here. That's what you're going to do. So I got to find f of 2 first. All right, well, no big deal. I can find f of 2. So f of 2 will be, now remember, you got to go to function 2 now. I'm sorry, your function f. So I'm going to go off to the side here. I'm going to find f of 2. So f of 2 will be negative 4 times 2 plus 2. Well, negative 4 times 2 is a negative 8. Negative 8 plus 2 is a negative 6. So that becomes negative 6. Okay? Plus, now I'll go to g of 2. So g of 2, now which function I go to, does it matter? I got to go to function 2, to function g, right? So that's going to be g of 2 will be 5 times 2 minus 6. So that's 10 minus 6, which is 4. So that's this, 4. Okay, so I get negative 6 plus 4, which is negative 2. Just like when we did this, remember? Just like when we did this, when we said negative 6 plus 1, we got negative 5. Okay? So I get negative 2. So our answer, the way it's going to look is this. So you'll probably see something like f plus g at 2 equal blank, and in the blank, you just put negative 2. All right? Now remember, from part 1, when we did part 1, see when I added those two functions, now they were different functions than these are, but when I added them up, I evaluated it at x, and I got a variable expression. Here, I'm combining those two functions at a real number, so I need to end up with a real number. Okay? All right. Now, let's look at the next one. Suppose, now this will be part B. You're done. You're done with that. That's all you do. See, it's not difficult. Okay, so let's look at part B. So still the same function. I'm using the same functions, but this time, let's say I want to find f minus g at negative 3. F minus g at negative 3. All right, now remember, subtraction is not commutative, so the order is going to matter. All right, so that means f of negative 3 minus g of negative 3, right? That's what that means. Okay. So I got to find, just like I did this, I got to find each of these values, and then I write them out and I combine them. So let's go ahead and find f of negative 3. So f of negative 3 will equal, now again, which function do I go to find this one? I have to go to the function f. And here's my expression. So that becomes negative 4 times x is negative 3, plus 2. Well, negative 4 times negative 3 is 12. 12 plus 2 is 14. So that goes here. Minus, subtract. Now I got to find g of negative 3. Well, g of negative 3, again, you got to go to function g this time. So be careful, because it's very easily sometimes to forget which one you need. So this is g, I got to use g. So it'll be 5 times negative 3 minus 6. So that's negative 15 minus 6, which is a negative 21. Okay? And so this becomes, and remember, you can put this in parentheses as subtracting, because you remember when we did, if I can get it real quick, when we did the previous lesson, part 1, remember here, we had to put this in parentheses, okay? Because those are all variable expressions. Here, I could put that in parentheses if I wanted to, but I didn't have to because it's just a numerical term. And so we all know that 14 minus a negative 21 means 14 plus a positive 21, right? And so I get, what's that, 35? So I get 35. And so you would say f minus g at negative 3 is 35. Okay, let's do a multiplication one. So let's say same function. So let's say in part C, we'll do part C right here. So let's say part C. So let's say I want to find g times f at, let's say, 0. All right, let's say 0. So g times f at 0. Okay, well, remember, what does that mean? Well, g times f at 0 means g of 0 times f of 0. And just like we did in the previous problems, I'll find each value and I combine like terms, or I perform the operation. In this case, it will be multiplication. So g of 0, I go off to the side, and I figure out what g of 0 is. So g of 0, remember, you got to go to function g now. So g of 0 will be 5 times 0 minus 6. 0 minus 6, which is negative 6. That's what this is. Times. Now I got to find f of 0. So I got my function f this time. So f of 0 will be negative 4 times 0 plus 2. So negative 4 times 0 is 0. 0 plus 2 is 2. So that's this. And so therefore, negative 6 times 2 is a negative 12. And so we get g times f at 0 is negative 12. Now, real quick, I just want to ask you, I'm going to do this part D. What do you think f times g at 0 is, real quick? What do you think? Quick. Yeah, so the answer is negative 12, right? Negative 12, because remember, multiplication is commutative. G times f at 0 means the same thing as f times g at 0. Multiplication is commutative. So the answer should be the same. Now, what if I asked you this? Now, remember a while ago where we had, let me see if I can find it. Oh, here we go. Where I had f minus g at negative 3 we said was 35. Okay? So I'm going to put that, I'm hoping you can see it. So I'm going to put that here. Now my question is going to be this, part E. What would g minus f at negative 3 be? Now here's my question. Is it also 35? Is it 35? No. No, it's not. No. Because remember, subtraction is not commutative. Subtraction is not commutative. All right? So you may say, well, what is it? Well, you could do one of two things if you want to. You can actually evaluate it, just like we did here using the definition. So by definition, this means g of negative 3 minus f of negative 3. And then do each one. You already found them, right? Didn't you already find g of negative 3? Well, g of negative 3, remember, where is it? Right here? G of negative 3 was negative 21 minus, and then f of negative 3, remember, was a positive 14. I want you to notice something, though. What's a negative 21 and negative 14? Well, that's a negative 35. Interesting, right? So f minus g at negative 3 was a positive 35. G minus f at negative 3 is a negative 35. Those are opposites. Remember that? Those are opposites. It's always going to be that way. So if you find f minus g at a particular value, and then all of a sudden you want to find g minus f at that particular value, it's just going to be the opposite. And it kind of makes sense because I want to bring you back to the previous lesson just real quick. I want to bring you back, if I can find it real quick. In the previous lesson, we had this. Remember in the previous lesson we found f minus g at x, and we got this expression, variable expression. And then we found g minus f, and we had this variable expression. I'm going to go ahead and put g minus f at x here. What do you notice? And we talked about that. What do you notice about these two terms? They're opposites. Negative x squared, positive x squared. Positive 5x, negative 5x. Negative 6, positive 6. So they're opposites. So this is the opposite of this. Or we can say this is the opposite of this. But again, as long as you're looking at f minus g versus g minus f. Okay? All right, so they're opposites. All right, just wanted to bring that up. All right, let's do division. Let's do a division. So f. Let's suppose I want to find g divided by f at, let's say, negative 1. G divided by f at negative 1. Now my question to you is this. Can I say f of negative 1 divided by g of negative 1? Can I say that? The answer is no. No. Because division is not commutative. So remember, subtraction and division are not commutative. So for example, 7 divided by 6 is not the same as 6 divided by 7. Okay? Those are two different real numbers. So whatever's listed in the numerator goes in the numerator. So this is going to be g of negative 1 divided by f of negative 1. And then I just find each one individually. So let's find g of negative 1. So again, my function for g of x, I got to find it, is right here. So 5x minus 6. Wherever I see the variable x, I substitute negative 1. All right? I'm going to go ahead and rewrite it. So g of x was this. G of x was 5x minus 6, and f of x is negative 4x plus 2. All right, so I've got to find g of negative 1. So I go to my function g, where we see the variable, I plug in negative 1. So I get 5 times negative 1 minus 6. 5 times negative 1 is a negative 5 minus 6 is a negative 11. So that's my numerator, negative 11. The denominator, f of negative 1, I go to my function f, and I substitute negative 1 for x. So f of negative 1 will equal negative 4 times negative 1 plus 2. Negative 4 times negative 1 is a positive 4. 4 plus 2 is 6. And then if possible, reduce if you can, but I can't reduce, so there's your answer. So you would say that g divided by f at negative 1 equals negative 11, 6. That's what you would say. Okay? All right, now let's look at one more example, and then I think you should be okay with the idea of combining functions at a real number. All right, so let's look at one more. Let's suppose we want to find, let's suppose in example 2, number 2, let's suppose in number 2 you're told f of x is and I'm going to use a different function this time. Let's say it is 2x squared minus 5x. And then g of x, and I'm going to use two quadratics. Let's say g of x is 5x squared minus 2. All right? Okay. So real quick, let's just kind of review basically what we did. So in part A, you want to find g plus f at 0, let's say. All right, well, so remember by definition that means g of 0 plus f of 0. Okay, so we got to find g of 0 first. So let's go to my function g and find g of 0. Well, g of 0 will be 5 times 0 squared minus 2. Well, 0 squared is 0. 0 times 5 is 0. And 0 minus 2 is a negative 2. That goes here. plus f of 0. So this time I go to my function f and I find f of 0. Well, that means 2 times 0 squared minus 5 times 0, right? Well, 0 squared is 0. 0 times 2 is 0. 5 times 0 is 0. And 0 minus 0 is 0. So, so, um, so g plus f at 0 is equal to negative 2. Part B. That's all you do. No big deal. You can handle that. Part B. Let's suppose I want to find, real quick, let's suppose I want to find g minus f at negative 3, let's say. Negative 3. All right. Well, by definition, that means g of negative 3 minus f of negative 3. And so g of negative 3, let's go off to the side and figure that out. So remember, I go to my function g, and wherever I see the variable x, I substitute negative 3. So I get 5 times negative 3 squared minus 2. Order of operations, I square first before I multiply. Negative 3 squared is 9. 9 times 5 is 45, and 45 minus 2 is 43. So this right here is 43. Subtract. Now we got to find f of negative 3. So to find f of negative 3, remember I go to my function f. This time I'm going to substitute negative 3. So I get 2 times negative 3 squared minus 5 times negative 3. Order of operations, I'm going to multiply first. I'm going to do the exponent first. Negative 3 times negative 3 is 9. Then I'll multiply. 9 times 2 is 18. A negative 5 times a negative 3 is a positive 15. And when I add them up, I should get 32. Okay? Sorry, 33, excuse me. 33, sorry. 33. So that's going to be 43 minus 33, which gives me 10. So g minus f at negative 3 is 10. Okay? C. Suppose I want to find f times g at, let's say, 4. F times g at 4. Well, by definition, oh, by the way, just kind of review. So suppose this was C. Suppose this was C. Suppose I want to find f minus g at negative 3. Real quick, tell me what you think that is. So g minus f at negative 3 is 10. Then what do you think f minus g at negative 3 is? Yep, you are right. It is negative 10. All right, good. It's just the opposite. All right, let's go back to, and let's call this D now. So D, f times g at 4. Well, by definition, that means f of 4 times g of 4. Well, we got to find f of 4 first. So let's go off to the side and figure out what f of 4 is. So remember, make sure you go into the right one because you can easily mess up. So f of 4, I got to go to my function f, means wherever you see the variable x, I substitute 4. So it'll be 2 times 4 squared minus 5 times 4. Order of operations, we do the exponent first. 4 squared is 16. 16 times 2 is 32. Minus 5 times 4 is 20. And so this becomes 12. So that goes here. Times g of 4. All right, so let's figure out what g of 4 is. So g of 4, I go to my function g, and wherever I see the variable x, I substitute 4. So that's going to become 5 times 4 squared minus 2. 4 squared is 16. 16 times 5 is going to be 80. And then 80 minus 2 is 78. So, therefore, 12 times 78, so 78 times 12 is 936. So I say f times g at 4 is 936. All right, and then finally, let's do the quotient with this. So the quotient, okay, so let's call this part E. So let's find f divided by g at, let's say, negative 1. F divided by g at negative 1. Okay, well, here are my two functions again, f and g. So by definition, remember by definition, that means f of negative 1 divided by g of negative 1, right? Okay, so let's find f of negative 1. Let's do the work. F of negative 1, make sure you go back to the function f though. So that's 2 times negative 1 squared minus 5 times negative 1. So negative 1 squared is 1. 1 times 2 is 2. Negative 5 times negative 1 is a positive 5. And so I get 2 plus 5 is 7. So that's my numerator. Now let's go to the denominator. Let's find g of negative 1. G of negative 1. So g of negative 1, I go to my function g, and where we see the variable x, I substitute negative 1. So I get 5 times negative 1 squared minus 2. Negative 1 squared is 1. 1 times 5 is 5. 5 minus 2 is 3. All right, so f divided by g at negative 1, at negative 1 is just 7/3. Real quick, what if I asked you to find g divided by f at negative 1? All right, well, if f divided by g at negative 1 was 7/3, then what's g divided by f at negative 1? Yeah, 3/7. And it kind of makes sense. It would be the reciprocal because if you actually did this, wouldn't that be g of negative 1 divided by f of negative 1? And we found g of negative 1. G of negative 1 is the denominator, right? 3. F of negative 1 was this numerator, which is 7. So you notice those are reciprocals. Okay. All right, so I think that's going to be enough for you to be able to get through the assignment that goes with this. All right, so that takes care of combining functions part 2.